Hi dear students, welcome to the next topic from magnetic effect of current. Last class we have discussed about different cases, or in the last sessions we have discussed about different sessions, and this is a different one, and we are moving something called a special cases which comes under this chapter, but it's more or less closely related to what you have studied so far. So let's move to the topics, and the next topic heading is called cyclotron. Okay, what is called a cyclotron? Cyclotron, it's a device which is used to produce fastly moving charge electrons. Fastly moving. So if we have a charged particles are there. Again, you have to note my word, which is called positive charged particle. So throughout the discussions, I have taken care about positive charged particle. Electrons or negative charged particle cannot be used with cyclotron. This is an important point. Electron or negative charged particle can't be used in cyclotron. The reason I will tell you at the end of this sessions of cyclotron. So now it's purely we are going to deal with what is this, what is meant by cyclotron and what is the use of this one. Cyclotron is actually, in short, it is a device. In your school labs, you have already seen something like multimeter or ammeter or voltmeter. Voltmeter, of course, you might be seeing it's a black dabba, right? That is used to measure voltage. Ammeter is used to measure current. So there are different lab equipments are there in your school labs also. So cyclotron is like a device, whatever you are seeing in your lab. So similar to that, this is also a one of the device. Okay, refrigerator is a device, television is a device. What is the purpose of refrigerator? To cool our products, whatever we have placed inside the refrigerator. But again, what is the use of cyclotron? Cyclotron can produce a fast moving charged particle. That is the use of cyclotron. So then the next question will come. Hey sir, what is the purpose of getting a fast moving charged electron? So fastly moving charged particles are required for various experiments. Okay, for example, in nuclear reactor it is required. So there are applications are there why we are using cyclotron. So three things I am pointing will be here. Cyclotron is a device. Okay, it's a device. Second one, cyclotron is used to produce a fastly moving charged particle. Then where it is using in our practical life, where it is using in nuclear reactor as an example. Not only nuclear reactor, many applications are, but that is the one of the application of nuclear reactor. So it's a device or a machine which are used to accelerate the charged particles in a very high speed. So let's write the definition. It is a machine or it's a device. Machine used to generate high accelerating charged particles. High accelerating charged particle. So machine is a device. The machine is a device or machine or a device which is used to not used to generate, used to accelerate the charged particle, at very high speed, at very high speed. So speed will be very high. So cyclotron is a machine which is used to accelerate charged particles at very high speed. This is what we are going to see, and where we are used this one. So this is a definition of this one. So this is a device we know This is a device, and wherever it's uses in nuclear reactor. This is used in nuclear reactor. Nuclear reactor, why we are used in nuclear reactor? For example, nuclear reactor application, you know, like nuclear fission, nuclear fusion. So nuclear fission and nuclear fusion are the process of bombarding one neutrons with some helium or some radioactive material. So that bombarding purpose we are using with a nuclear reactor. Second one, for inserting an ion into a solid. There are some chapters are there at the end of this physics chapter. You will learn one chapter called semiconductor electronics. So there we will learn something called a doping. Doping, it is a process of mixing one material with another material, that is called doping. So this doping process can be done, means inserting an ion, which means it may be any other chemical compound which is inserting to some other chemical compound in order to happen certain chemical reactions. Okay. The third one is like this device is also used to start radioactive decay process. Our next major topic is from physics, modern physics area is radioactivity. You have a chapter. So used to start radioactive decay. These are the constructions these are the uses of this one. Next we are going to see the construction of the device. Okay, how the device is made up of. So let's have a look into this one. So construction and working, this is important to know. Okay, constructions and working. Okay. Okay, so cyclotron, as I told, it's a machine, it's a device. Okay, so let's have the diagram first. So this is like a chamber, a closed path, and this closed path consists of some electromagnet, which we call it as Ds. Ds means its shape is called a D-shaped structure. That's what it is called, a Ds. Okay, two Ds will be there. This is something like a what we call it as an electromagnet. So there are magnetic fields which are coming outside. That's what I am putting as a dot. So magnetic fields which are coming outside. Okay. So magnetic fields which are coming outside, but the point is like the magnetic fields are not present between the Ds. So between the Ds there is no dots, only outside and inside of the Ds. Between the setup is like this one. So the magnetic fields are available outside or within the Ds. Okay, so at various points within the Ds, the magnetic fields are coming out. That's what the dot signs indicate. Right. What is the other speciality of this one? This Ds is connected with a high frequency sine wave connector. Okay, very high frequency, very high voltage. So if you see something in physics like this is something called an oscillator. This is an oscillator. This oscillator can produce a fast moving sine waves. Okay, so this will produce us very high frequency and very high voltage signal. Okay, this will produce us very high frequency, very high voltage signal. So very high frequency and very high voltage signals can produce this one. So if it is producing a very high voltage, then what will happen? Here this is a positive wave. So initially this plate is positive, then this plate is negative initially. So first I am assuming this is a sine wave which is coming. So initially positive pulse is coming to this one, then during the time negative pulse is coming to this one. So now here it is positive pulse, here it is negative pulse. So when positive pulse will come, this is positive and it is negative. In the next second, what will happen? This will become negative and this will become positive. So all over will be here become negative, negative, negative. Here positive, 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 positive. Okay. So this process will be getting, this will be keep on switching, and the polarity is keep on switching between positive and negative. So at the moment I am marking as positive to understand, and this is negative at the moment. Next, in the center we have something called, okay, we have one dots will be there, and this I would like to indicate like this one. So this is the source of the charged particle. So what this means is that this is the source of the charged particle. Source of the charged particle. Source of the charged particle. Sources. Charged particles and the source charges will be producing, and this is called D's. Okay, this is the magnetic field which are coming outside, and these are called functional oscillator. Okay, and this is called a chamber. So all things will be there. Next we are going to see the working conditions of this one. Okay, this is a kind of a hollow metallic piece. This D's is a hollow metallic semicircular container. Okay, D's. What it is called D's means we can write what is called D's. It's a hollow metallic semicircular conductor. Semicircular conductor. Okay, so D's will be there. Oscillator, very high frequency, very high voltage signals will produce. So one plate become positive at a time, so the next plate may become negative. After some time this polarity will be getting changes. We will see the working of this one. So this is a construction. So hope this is very clear to you. Very simple diagram. Okay, so next we will see when a charged particle is producing here. When a charged particle is produced will be here. So a charge will be here. So let's assume we have a charged particles will be here. So the charged particle is started from here. When a charged particle, this is a source which is producing the charge. In your school standard you may hear a word which is something called electron gun. So this is similar to a gun, but this is not an electron gun. This is not producing electron. Whenever I am writing plus Q, which means it is positive, it's not negative. So this oscillator cannot be used with an electron. There are reasons will be there in the first statement. When starting this chapter itself I mentioned the point. So we'll see what happened here now. It's a positive charged particle. So whenever the positive charged particle immediately comes out of the D's, this will see, and positive plates will be here and negative plates will be here, and the positive plates and negative plates will lead rise to what is called an electric field. Okay, so an electric field will be getting generated. So whenever here, now the electric field direction is like this. Electric field direction is like this means there is a force will be there. What is the value of that force? F is equal to QE. F is equal to QE. The direction of F is same as the direction of electric field. So the direction of electric field and direction of the force both are same, one and the same. So electric field direction same as the force direction. Okay, so F is equal to QE, electric field, force equal to electric field. Okay, so we'll see. So now force will be equal to electric field, direction of force is same as the direction of electric field, which means a force will act like this one. So what happened? The charged particles will move towards the D's. It will move means it will accelerate, because here there is no magnetic field, only electric field. So we can say we have certain points will be here between D's only E, which means E is not equal to 0, but B is equal to 0 between the D's. So what will happen? The charged particles, what will happen to the charged particle? Charged particles get accelerated between the D's. If you know the story, you can write down. So this will get accelerated. Once it is accelerated, what will happen? This will enter into this D's. Within the D's, what is available now? A magnetic field. So magnetic fields are coming outside towards you. So a magnetic field which is coming towards you. So in this case, what will happen? A positive charged particle is moving from left to right. A magnetic field which is coming towards you. In this case, what will happen? Charged particle is moving perpendicular to the magnetic field will undergo what type of motion? Circular motion, perpendicular. Other than perpendicular, it is called helical motion. So this is not helical motion, it's a circular motion. Circular motion means this will try to rotate like this one. So the charged particle now rotate. Again, what happens? So whenever this will take some time, suppose you assume 1 second time taken from moving to here, during the time whenever it is reaches will be here, what happen means this plate polarity become positive and this plate polarity become negative. So there is an opposite electric field will be there. Now this plate become positive because we are giving a sine wave. One is positive, next time it is negative, next time it is positive, next time it is negative, and keep on going. Now this plate become positive. Once this plate become positive means an electrical force F is equal to QE in the other direction, opposite direction. So what will happen? These electrons will get accelerated. In this direction. Again we have a magnetic field, but here the point is like that. This will take a big circle comparable to this. Why? Because you know the radius equations are equal to mv divided by qb. This radius equations you know. So here you can see whenever velocity increases, radius increases. Initially this is accelerated by this electric field. After a round, this will be again accelerated by the electric field with very high speed. Whenever speed increases, next time the radius is increases. So this is now the new radius r dash. This is the older radius called r. So whenever speed increases, so first small speed, then take a rotation in a magnetic field. This will move with what speed? Constant speed. So from here to here, if this velocity is v1, then this velocity is v1. Both velocities are same. But it is accelerated. Now the velocity is v2. Then with the constant velocity it is rotating. So it become v2 will be here. But what is the major point will be here in the sense? This will undergo a big circle because velocity increases, radius increases. So means as v increases due to F is equal to QE, more force, so more speed. Okay, so R also increases, radius also increases, which means what? Bigger circle, which means a bigger circle will come into picture. Now this will undergoes a big circle. After reaching here, again you can see our red polarity. So now this plate become positive, this plates become negative. So again electrons will get accelerated. So here velocity v2 means speed increases. So now the new velocity is called v3. Once it is reaches v3, speed increases means again radius will increases. This will take a big circle like this one. So what is the velocity will be here called v3. Now again speed increases, so it become called v4. It will take a big circle, speed will be v4. Again polarity changes, so it accelerated, speed become v5. This will go. So here it cannot, so which means its radius is almost equal. Now if it is rotating means this will rotate like this one along the D's. Whenever it is touching on the D's, here you can see something called an exit window. You can see something called exit window. Once it is touches on this disk, there is placed something called an exit window. So through the exit window, the charged particles will go out. The charged particles will go out. So what is happening? Initially a charged particle is coming in between the disk, accelerated, rotated, accelerated, rotated, accelerated, rotated, accelerated, rotated. High speed, it is keep on, its speed increases and finally shooted up. Okay, shooted up with what? High speed, high speed. Okay, charged particles produces by the source of the charged particles will be a accelerated rotation, accelerated rotation, accelerated rotation, accelerated rotations going out. Through where? Through the exit window. Through the exit window. Okay, through the exit window. So through the exit window, the charged particles will moving outward with very high speed or very high velocity. Okay, so this is clear. So between the disks, the charged particles will get accelerated. So from here to here velocity will be the same. This is called a V1, right? There are no change in the velocity, because in a magnetic field charged particles will undergo circular motions with constant speed. If you look back to my note, whatever I have given in the previous session, you can see I have given a word called constant speed. I have underlined that word. So this will undergo a constant speed V1 to V2, V1 to V1 here. Then speed increases because of electric field, electrical force, because of high force it is accelerated. Then V2 speed reaches here. Then again its speed is same. It will undergo a rotation motion. Not rotation motion, circular motion. Then after V2, again electric field increases its speed V3. Again undergo circular motion with the same speed V3 here, V3 here. Again speed increases. It become V4. Again it is rotating. Again speed increases. Then coming out of the exit window with very high speed. So this is the purpose of cyclotron. Machine is a device used to accelerate the charged particle at very high speed. Charged particle means it should be very clear. You can write, if you want you can write only for, not if you want, you have to write only for plus q, only for plus q. Okay, we will see the limitations of this one. So only for plus q. So this charged particles, we know this is moving with a very high speed. Okay, charged particle is moving with a very high speed. Now take down on your note and write the following points, whatever you understand. So between the disk, electric field is between the disk, only electric field, magnetic field is equal to 0. So a charged particle, a sourced charged particles will produce a charge. This will get accelerated between the disk and having, then it will undergo a circular motion within the disk because of the magnetic field. Whatever I am telling, you have to pause the video and write it as a sentence. Okay, so sourced charged particle produces the charge accelerated between the disks. Then it will undergo circular motion within the disk with the constant speed. Within bracket you can write V1 equal to V2. Then what will happen? Again now you can given as D1 and D2. Now D2 become positive and D1 become negative. Again it is accelerated. Then it will undergo a circular motion with constant speed. Then accelerated. Then undergo constant speed. Then this process will continue. After some time, these electrons will be going out of the exit window. Polarity of D1 and D2, these are changing frequently. So whenever this is reaches exactly here, at this time this plate become positive and this plate become negative. Whenever this reaches will be here, exactly at the same time this become positive and this become negative. So this will get happens. Okay, hope the working or the condition, how the cyclotron is working is understandable to you. Okay. Now let's see some mathematical related stuffs will be here. We know the charged particles are moving with a very high velocity. Okay. So we know the radius equations. R is equal to mv divided by qb and v is equal to qbr divided by m. Okay. So we know the charged particles, what will happen to the charged particle? Charged particles moves with high speed, which is something called v, and its kinetic energy is equal to half mv square, which is equal to 1/2 times of m times of q square b square r square by m square. So once we simplified, we got q square b square r square times of 2m. 1m got cancelled. This is the equations for kinetic energy. Remember this equation, sir. Equation as such, it will ask us a question for your entrance examinations. Okay. So hope this is clear. So of course we know the time period of the oscillator and frequency of the oscillator. Okay, so the next point, this is an oscillator which is producing a sine wave signal, so which will have something called a time period. So time period of the oscillator, we already know the time period equations, 2 pi m divided by qb. This is a time period equations. Okay, so I want to write one more point. So of course once we know the time period, frequency is 1/t, which is equal to qb divided by 2 pi m. So remember these equations also. Frequency, this already we have written, but still, yeah, remember these stuffs. This is important to know. Okay, fine. Okay, so fine, great. So next we are going to see the limitations of cyclotron. Limitations of cyclotron. We'll see limitations. There are couple of limitations are associated with this one. So let's see the heading called limitations of the cyclotron. Limitations of the cyclotron. What is the limitation of the cyclotron? There are two limitations, have to say. So number one, cyclotron which can't be used to accelerate, neutral charged particles. We can't be used to accelerate neutral charged particles. Okay, neutral charged particle cannot be accelerated. Either it should have charges, which means it should have positive charges. Next one, can't be used to accelerate electrons within bracket negative charged particle. I will tell you the reasons why we can't use electron within cyclotron. The reason is quite simple. Okay, listen very carefully. Bit tricky, at the same time very conceptual also. So the reason is like, I'll tell you the reason, we'll come to a conclusion, then we'll understand, okay, because of this one it's not possible. So mass of electron is less than the positive charged particle. What is that? Is called proton. So mass of proton. Are you agree with me? Mass of electron is less than that of mass of proton. So whenever mass of an item is very lesser, suppose I am a guy, my weight is 60 kilogram. Okay, my original weight is also 60 kilogram. So it's 60 kilogram. Suppose another fatty guy will be there and whose weight is, for example, a 90 kilogram. So a 90 kilogram guy and a 60 kilogram guy ready for a race of 100 meters. Of course, I can run bit faster than the other guy, right? Because my weight will be less than that of the other guy. So very less weight, very less mass, I can move very fast. So which means speed of electron greater than speed of proton, speed of electron greater than speed of proton. We have Einstein mass energy relationship is equal to mc square. So there is also a relation which is connecting between m equal to m0. I don't know whether you heard these equations or not, else you hear it now. 1 by v square by c square. 1 minus v square by c square. M is called moving mass. I'll tell you what it is. Moving mass. M is called moving mass. M0 is called rest mass. I'll tell you what it is. For example, moving mass means whenever I am running, so I should have a speed, I should have a mass. That mass is called a moving speed. Whenever I am standing, I am rest positions, I have a speed, I have a mass, that is called rest mass. Rest mass is a mass in which I am not moving, and moving mass is the mass in which whenever I am moving. Okay, I told my weight is 60 kilogram. So whenever I am running with a certain speed, so normally C is called velocity of light, 3 into 10 power 8 meter per second. I cannot run that much speed, right? I will run in maximum like maybe some 20-25 kilometer per hour. That is my maximum speed. So comparable to my 20-25 kilometer per hour means that is very less, very less than that of 3 into 10 power 8 meter per second velocity of the lights. So whenever I am running, my speed is v is almost negligible, nothing, zero. So in that case, my moving mass equal to my rest mass, because v is equal to 0 means root 1 m equal to m0. My moving mass same as my rest mass. That's what if you are running or if you are standing, your mass will be almost the same, because your mass is very less comparable to the speed of light. It's very fast. But when come to the context of electrons can move with very high speed. Very high speed means the velocity of an electron is very high, or it is nearly equal to, or more or less equal to, or it is comparable to that of C. Okay, so this should have some value will come. This factor is not 0 as like my case. This is not 0. We should have some value. So once you do this one, suppose you got a value called 0.8 will be here. Suppose v square by c square, you got a value called 0.8. So 1 minus 0.8 you will get. 1 minus 0.8 means root of 0.2. So denominator is very less. Root of 0.2 means suppose you got some 0.00.1, for example, you got some value. So m0 divided by 0.000002, for example, then the m will be very higher, because numerator is, so because the denominator is very less, 0.00 something. So earlier cases, when you see, when v equal to 0, m equal to m naught. Okay, so the next case, when v is not equal to 0 and comparable to c, then what you will get? For example, root of 1 minus v square by c square has a fractional value. For example 0.002, I keep it like this one. For example, now if you do like this one, what you will get? M equal to m0 divided by 0.02. You will get m0 divided by 2 into this 0.02 into this is 2 into 10 power minus 3, so this will go to 10 power 3, so it become 1000 m0 divided by 2, which become 500 m0. See, this is very higher than m0. So which means in this example context your m increases. Okay, so when V is not equal to 0 and comparable to C, for example, if this value will come, so this is happening in electron. This is happening in electron because V is comparable to C. V is not 0. V can be comparable to C. So whenever V is comparable to C, this should have a value. So moving mass is greater than that of. So I am writing for electron, the further points for electron, M much greater than M0. Moving mass is greater than M0. Moving mass. This is called rest mass. Mass of electron. Mass of electron means rest mass. Mass of electron means rest mass. This is also called rest mass. Rest mass of electron less than rest mass of proton, I know. But when the electron is started to move, its mass will be very higher. As per according to this relation, this equation is given by as a derived form from Einstein equation. Okay, you got it. So mass will be higher. What is our time period equations? 2 pi m by qb. What is our frequency equations? It is qb divided by times of 2 pi m. Whenever this is our frequency equations, according to the frequency equations, when m increases, frequency reduces. Less frequency means, more frequency means what? It can rotate very fast. Between the two Ds, it can rotate very fast. That is the meaning of high frequency. Whenever which will have less frequency means what will happen? Slow. It cannot resonate. Resonate means it cannot rotate. Less frequency means electron can't resonate between the Ds. Between the Ds, these electrons can't resonate. This electron can't resonate means I can say electron not fit for cyclotron. Okay, so it cannot oscillate. That is the main problem. It cannot oscillate. If it cannot oscillate, means what is the purpose of putting electron in cyclotron? Not possible. So this was the reasons. I am repeating once again. Mass of electron is less than that of mass of proton, which means a rest mass. So speed will be higher. Mass will be lesser means speed will be very higher. So according to the equation m equal to m0 by 1 minus v square by c square, this is a relations which is derived from Einstein mass energy relationship. You will learn this in modern physics. This is called moving mass. What is the mass of an object when it is moving? What is the mass of an object when it is at rest? That is called m0. When velocity is equal to 0, m equal to m0, that is happening normal in our case. Whenever a small lighter charged particle, for an electron, velocity is not 0, velocity is comparable to that of c. For example, if I am taking a value called 0.02 for the entire denominator, 1 minus v square by c square. So v is not 0, negligible. It has significant value comparable to the light speed. If you do like that, if you give that value as an example, you will get moving mass is 500 times that of rest mass, because mass is higher. When mass is higher, according to the frequency equation, f is equal to qb by 2 pi m. This is an oscillator equations, oscillator frequency, which means this charged particles which are rotating between the Ds and going out. So it has to resonate. So whenever the mass will be keep on increases, frequency keep on reduces. Whenever it is tried to accelerate, mass is increasing. Mass is increasing means it cannot oscillate. It is a lazy man. Mass is keep on increasing means it's a lazy man. Frequency reduces, which means electrons can't resonate between the D's. Electron, it can't resonate means it can't rotate, it can't go out of the exit window, which means electron is not a fit for cyclotron. This is the two limitations of the cyclotron. Hope you understood.